Hi everyone, welcome to today's tutorial. So in this tutorial, we're going to discuss how you can evaluate definite integrals. So if you have not yet subscribed to the channel, make sure that you do so by clicking on the subscription button and also the notification button. If you have any questions, feel free to contact me on any of these lines. Alright, so let's quickly begin. So we have this question, which is asking us to evaluate the definite integrals. So looking at the number of questions, there are a lot, so I'm not going to solve all the questions. I'll just pick random questions because the procedures are just the same. So the first question is which is the integral of 2 then 0 6x with respect to x. So the first thing that you need to do with this question, you integrate what you've been given. So I'm going to open square brackets and then I'll put my integral inside there. So integrating this, 6x will give us 6x squared over 2, then over the interval or the limits 2 and 0. So 2 into 6, you are getting 3. Then you have x squared to 0. So what you just need to do now is to replace the upper limit in the given expression, in the expression that we found there. Then you also replace the lower limit. So when we replace the upper limit, we're going to have 2 there squared minus, then we have the lower limit there, which will give us that. So this part will give us a 0. Then here we're going to have 3 times 4, which will give us a 12. So 12 is the answer for that. So in case you've been asked to find the area bounded by the curve, and then if these are the limits that you've been given, you always have to add units squared if it's area. If it's volume, units cubed. So for volume it's the same thing, but you always have to add pi. And you also, for volumes of revolution, you always have to add pi, and also you square the function, and we're going to discuss that. Alright, so this other one, we have the integral over the limits 1 and negative 3 of 8 with respect to t. So differentiating this with respect to t, we're getting 8t. Then the limits, we have 1 and negative 3. So the upper limit is 1, so I'm going to replace where there's t with 1. And then the lower limit, we say minus. The lower limit is, so I'm going to open the brackets. Where there is t, I'm going to put negative 3. So this will be 8 times 1 to be 8 minus. So 8 times negative 3, this will give us negative 24. So this will be negative times negative 24 will get 8 plus 24, which is just 32. So this will give us 32 as the answer. So let's also do this one. So that one is also straightforward. What you just need to know is how to integrate. If you know how to integrate, putting in the limits is not a problem. So we integrate that. The limits 0 and negative 1. So 2x minus 1 with respect to x. So integrating this, we're going to have 2x squared over 2 minus x. So we have to put this in brackets, and then the limits are 0 and negative 1. So when we simplify this, we're going to have x squared minus x. Then okay, let me just write the brackets. The brackets are we have 0 and negative 1 there. So when you replace the upper limit, which is 0, in the expression, we're going to have 0 squared minus 0. And then we say minus, we also replace the lower limit. So the lower limit will be negative 1 squared minus negative 1 there. So when you simplify the expression, this whole part will give you a 0. So just remain with negative. Then inside there, we're going to have negative 1 squared. That will give us a positive 1. The negative times negative, that will give us positive 1 as well. So 1 plus 1, that is a 2. So we have negative 2 as the answer. The negative is coming from here. Alright, so let's also do let me pick a different, at least something that looks unique. Okay, let me solve this one. So integration is simple. So the integral on the limits 3 and 1 of 4x cubed minus 3x squared with respect to x. So the first thing that you do is you integrate the given expression. So 4x to the power 4 over 4. Then we have minus 3x to the power 3 over 3. The limits are 3, 1. So when we simplify this, we're going to have x to the power 4 minus x to the power 3. Then over the limits 3 and 1. So here is just a matter of replacing in the limits. While this x we put 3. So we're going to have 3 to the power 4. Then minus 3 to the power 3. And that's for the upper limit. And then we also replace in the lower limit. So the lower limit is 1. We put 1 there. Then minus 1 to the power 3. So this part we're going to have 3 to the power 4. That is 27. I mean 81, not 27. 3 to the power 4, that's 81. Then minus 3 to the power 3, this is the one that gives us 27. Then we say minus 1 to the power 4, that's 1. 1 to the power 3 minus 1. So in short, this part will give us a 0. So 81 minus 27. So 81 minus 20 is just, I think, something like a 54. Yeah, it gives us 54. Alright, so this is how you solve that. So let's see another question which we can solve together. Which one can you solve? Okay, let me get one trigonometric question. Let me get this one. Let me start with this one. Okay. Alright, so let's see how we can solve that. So we have this one, which is pi, and then we have 0 there. 1 plus sine x, then dx. The integral of 1, since we are integrating this with respect to x, will give us x. The integral of sine x will give us negative cos x. Okay, and then we have the limits as pi and 0. So what you can do here is this one is straightforward. What you can do here is just replace pi while there's x there. So when we replace pi while there's x, let me write it this side. We're going to have pi minus cos pi. So pi in degrees is simply just 180. And then we say minus, the lower limit we put 0 while there's x. So we're going to have 0 minus cos 0. So cos pi is simply just going to give us negative 1. So pi, we have pi there, then we have minus, and then we're going to have negative 1 because cos pi is simply just negative 1. Then we say minus, we have a 0 there, and then cos 0 is simply just 1. So we say minus negative 1 there. So we can simplify this. When you simplify this, we're going to have pi plus 1, then minus 1, which gives us pi plus 2. So this is the solution for that. Let's look at this one as well, because this one is straightforward. The integral, of course, is simply just sine. So now let's look at this one. So the other questions which I've skipped, you can solve them and then see if you're going to get the correct answer. If you doubt your solution, you can send the solutions over to my WhatsApp line. Then I'll check for you whether you're correct or wrong. So we have this one, which is the integral over the limits pi over 4 and 0 of 1 minus sine squared theta over cos squared theta d theta. So this one, when you look at the numerator there and the denominator, this one is giving us a 1. I don't know if I'm the only one seeing a 1 there, but yeah, it's giving us a 1. So because we know to say the Pythagorean identity is cos squared theta plus sine squared theta is equal to 1. So we just make cos squared theta the subject, meaning we take sine squared theta on the other side of the equal sign. So we say cos squared theta is equal to 1 minus sine squared theta. So when you replace it there, you're going to have the integral of pi over 4 0, then 1 minus sine squared theta over 1 minus sine squared theta. You see the one that I was talking about. So this part gives us a 1. So that's just the same as integrating that over the interval pi over 4 and 0 of just d theta. So when you integrate that, you are going to get theta as your solution. Then you have to put the intervals, rather the limits pi over 4 and 0, meaning your answer will simply just be pi over 4 minus 0, which is just pi over 4. So that is how simple this question is. You can also try to simplify this part before you integrate it. So thank you very much for watching today's tutorial. Make sure that if you have not yet subscribed to my channel, you click on the subscription button and also the notification button. If you have any questions, you can simply just send them over to this to any of these lines. They are all on WhatsApp, and even on Facebook or on Telegram you can use the MTN line. Okay, see you in the next tutorial video. Shalom shalom.